Hi, welcome to flexiWAN Academy. In today's lesson, we're going to be covering IPsec peering with cloud services and third-party routers. So let's get started. So for today, the lesson agenda is, what we'll be covering today is what is IPsec peering, how it works, what is the functionality, its use cases, and finally, we'll do a demonstration, depending on how much time we will have during the demo, demonstration to how to connect to AWS, and probably also or at least show you how to deploy it with the third-party device. So let's get started. As always, let's start the webinar, the lesson with the documentation pages. So definitely, definitely check out our documentation, docs.flexiwan.com. And here in this IPsec peering section under management, you can actually get a more detailed insight of the way everything works. But in general, so we want to cover, do a short overview. So what is IPsec peering? So this is the feature that allows connecting IPsec tunnels between FlexiEdge devices and other peers. So what's peer? Peer, it can be a cloud-based provider that provides cloud security, or SASE provider. Can be used for like Amazon, to connect to the Amazon site-to-site VPN, to connect to your Amazon resources like AWS, or to be used for network aggregation. And finally, a peer can be also a third-party network device. So let's say you have an existing networking infrastructure and you want to also add flexiWAN, and you don't have flexiWAN on every single site. So instead of that, you can connect IPsec tunnel. You can connect flexiWAN to an existing infrastructure, as long as they have supported IPsec, which in our case is IPv2, and supported ciphers and encryption settings. And yeah, that's it. Basically, that's a general overview. We're not going to go into too many details, but keep in mind a few things. Is that we use IPv2 IPsec. So basically, any third-party device or service that can match these parameters should be able, in theory, should be able to establish tunnels with FlexiEdge devices. We support both routed and policy-based connections. However, we definitely suggest using routed connections, because this is the way that you will have really the least hassle in your configuration. Keep in mind that this is IPsec and this is IPv2, so we use UDP ports 5500 and 500 and ESP50. So this is not for FlexiWAN, it's for the other side. You may need to be able to open ports. And yeah, that's it. In general, we have tested this in a number of scenarios already. And while I'm going to demonstrate here today about how to establish to Amazon AWS VPC, it's also possible to connect to third-party devices. And I need to double check. Yeah, so basically, this is the list of the so far tried devices and services. One is Amazon site-to-site VPN, through which you can then gain access to your internal Amazon resources. Crypto Gateway is another cloud provider that provides this same functionality. Oracle site-to-site VPN. And then lastly, we've tested establishing tunnels, IPsec tunnels via IPv2 to the following vendors, basically Checkpoint, Meraki, and pfSense and OpenSense. We've tested tunnels can establish without any too big hassle. So let's get started. So here on this site, we have on our account, we have 5 devices in our lab environment. But the difference here is that if we go under network dashboard, you will see here that we actually have tunnels between these few local sites and 2 also sites that are for peering. One site, Madrid site, already has a peer connection, and this is how it's represented in the terms of the graphically represented in a cloud. And the Frankfurt site will be the one that we will be adding the peering, connecting the peer from Frankfurt to Amazon site to site. So to recap, we've covered what IPsec peering is. Definitely check out our documentation pages for more detailed overview about everything. But for more actually details, not overview, for the more details. So let's get started. Basically, we want to connect our Frankfurt site to Amazon, AWS, site to site, in order to access company resources. That's the plan for today. And one of the things that you'll first notice is, here in flexiWAN, we have peers. And this is the function where you actually add peer. And if you click new, you can add peer, and you can see that pretty much the parameters that we offer are very, straightforward and very, pure IPsec, implementation, which supports any kind of, possible combinations of cryptographic parameters, and for IC and for ESP, and finally traffic selector. But this is on flexiWAN side. What's not present here is the remote side. This comes. Now we come to the first point. When using peering, you have to keep in mind that it may not be that straightforward as with connecting other tunnels. Like, for example, we have multiple sites here, and we connected tunnels in just a few clicks. And that's the power of flexiWAN SD-WAN. It's, you select a few devices or all devices, and you click connect, and tunnels will establish. And in the background, all of this IPsec and configuration and device configuration is sent automatically, and it's SD-WAN, so it works in just a few clicks. But while with peers, you have to keep in mind that only one side here is the SD-WAN, while the other side is still traditional networking. Of course, assuming that you're not trying to connect to another SD-WAN solution, but still in that case, again, you have to configure IPsec. So it's a lot more manual work, a lot more manual labor. So it's not going to be as easy, as straightforward as just connecting two flexiWAN sites. So, which is why we definitely suggest that you always keep in mind and keep this in mind, and try to use flexiWAN whenever you can, just to have a hassle-free deployment. So yeah, that's it. Let's just get started. So we have here already an existing peer. So we'll start from the scratch. So the goal is to connect my Frankfurt device to Amazon. And to do that, we have to go to Amazon pages, and here we have the virtual private cloud section, and you can see that we already have a company VPC. So that's the prerequisite. We require a virtual private cloud to VPC to exist, and if it doesn't exist, create one. We use the default network range 10.0.0/24, and of course, if this goes without saying, that we also require a pre-configured flexiWAN instance. In our case, this is Frankfurt instance, and here you can see that it has a single WAN and single LAN, just to keep things very straightforward. And you can see that here we don't have any tunnels between Frankfurt and the other side. Only Madrid has already an existing peer. So moving forward, let's move back to Amazon. So we have a VPC. You also need to have a subnet configured. We use the same 10.0.0/24 subnet. So now we also require internet gateway, which is from where you connect your VPC, which is how you connect your VPC to the internet, from where it gets an external IP. So let's assume that these resources, VPC, you have a bunch of resources here, and your company servers, and you want them to be able, you want to VPN to them, you want to establish tunnel to them to reach them via flexiWAN. So first you have to create an internet gateway. So we'll call it company gateway, create gateway. And of course, you have to attach it to your existing VPC. You can also create a new VPC if you don't have it. It's just if you click, keep everything as default. If this is just a pure demonstration. So that's about it in terms of the VPC configuration. We now have to configure the part where we connect to flexiWAN. So the first thing that we're going to do is we're going to scroll down a little bit here to virtual private network and customer gateways. So what's a customer gateway? Customer gateway is actually a remote FlexiEdge site. So you want to create a new gateway, and here you want to call it. So we'll call it Frankfurt. Actually, let's call it flexiWAN. And we'll just go here and copy the IP address. And let's also call it Frankfurt, which is the name of the device. We click create, and that's it. The gateway is now created. And we have added, we have identified flexiWAN gateway to Amazon. The next step is to add a virtual private gateway and attach it to virtual VPC. So to do that, we call it G, and just click, to keep everything as default, click create. And finally, right click, attach to VPC, company VPC, an existing VPC that we already have. So also, just to double, it's now attaching, there it is. Also, let's move forward on the, oops, sorry. Let's move forward. So finally, yeah. Okay. So we have added customer gateway, which is available. We have added, to recap, we have added virtual private gateway and attached it. And now it's the point to add also a new VPN connection. So create a new VPN connection. We'll call it company VPN. We're going to use an existing company VPN gateway. We're going to use Frankfurt as a gateway, customer gateway ID, which is the remote site. And this is the company gateway top. And here, this is the most important part. And let me actually increase fonts a little bit. And we're not going to use BGP. We're going to use static. And here, this is where we have to define static IP prefixes, which are actually the networks that we're going to allow the communication. So from this is the network at AWS, while the other side is the Frankfurt side, which is this network. So it's LAN side. So go here and so here we have defined everything. And so just double check. So company VPN, virtual private gateway, attached it to an existing ones. And that's it. Just to point out, we are going to actually, Amazon gives you 2 tunnels for redundancy. So we will get we'll actually configure in this demo. We're going to show you how to do this twice, how to configure 2 tunnels, just for redundancy purposes from flexiWAN to Amazon. So click create VPN connection. Excuse me. And it takes a little bit. Now it's created, it has created the VPN connection. So now it's the time to actually connect. Now that the VPN connection is created, we need to gather the configuration and deploy it in flexiWAN. So to do that, just click download configuration. And Amazon offers a pre-configured configuration, but we're just going to use the generic vendor agnostic. And just make sure that this is the section to pay attention is use IP2. Click download. That's it. Close it here, and we can open what they gave us. So basically, fonts a little bit. Hope this is visible enough. So basically, Amazon gives you a neat little document where they explain all the connection parameters and IP addresses that need to be used for in order to connect to it, to connect via site to site. So these are the pre-shared key and the settings of the encryption settings, and actual tunnel interface configuration that is also required. And you'll notice that this is actually for the first tunnel. So here is the IPsec tunnel 1, and at the bottom of this, there's also IPsec tunnel 2, which also we're going to be adding during this demo. So before we start, just to summarize, we have now created everything on Amazon side. We have a VPC, we have subnets, we have defined flexiWAN in customer gateways, added virtual private gateways, and we have configured company VPN. So now comes the time to actually create configuration on flexiWAN side, and that's a lot faster and a lot easier. So all we have to do is open this file again. This is the configuration parameters. So we're going to go to peers, and we're going to click. Actually, let's move once. No need. Actually, let's continue first, and then we'll add. Then I'll make a few notes. So basically, we need to start configuring peering configuration in flexiWAN. In this VPN configuration file, we have everything we need, and so under peering, we can create a new peer, add a new peer. So for this, I'm going to move it, to make things easier to view. We're going to move the instructions on the other monitor, and here we'll call it AWS1. ID type will be IPv4. Local ID will be automatic, and remote ID is actually found in the document that they sent, and which is outside IP of the remote of the virtual private gateway. So that's it. This is the IP that we are using, and that's going to be both remote ID and remote IP. And for peer monitoring, we are going to use an IP of the next hop, which is this one, and which is the virtual private gateway IP. And you'll notice here that there's also inside IP address, which is customer gateway. We'll cover this in a few steps later. So here we have now, and this is what we're going to be. Again, we're going to be pinging it when inside. We're going to be pinging virtual private gateway. So from the cryptography parameters, all of it is already, all of these default settings are good to go. They will match. And to keep things easier, use this IP range for the whole all possible IP ranges, because if you're doing just a demo or testing, you keep the traffic selector. If you need more security, add specific ranges that you want to use. So finally, I forgot to add the pre-shared key, and pre-shared key is here. It's added in the document, and that's it. Now that we have the pre-shared key, let's click save. AWS 01. So the next step is to connect this Frankfurt device to AWS. However, before that, we need to create a path label, which we're going to be assigned, to which we are going to attach or create a connect used for creating connecting peer to AWS. And to do that, just create AWS1 site, and let's click add. And let's also create a second one. It's a different second. So we have two. So let's go to Frankfurt. And here we're going to do AWS1. Let's use just one for now. Update device. Now that we have added the path label, now we're going to show you how easy it is to connect this pair that we already created. And to do that, you just simply select the device on which you want to deploy peer, actions, create peer connection, select the path label that you previously created, in our case, AWS1, and match it with the peer that we've just added. And that's it. Now, you can see at the bottom of the list, another peer has been added. And hopefully in a few moments, it will connect, assuming that I did everything correctly. Otherwise, this will turn to troubleshooting session. But yeah, let me actually refresh here. It takes a little bit to show it, but in the meanwhile, if you go to network, we can actually see the line, and yeah, it should probably, you can see the graphical diagram representation that now Frankfurt is connected to AWS, and here you can see Frankfurt indeed is connected to AWS. So we have now the tunnel and the peer has been connected, and you can see it's really fast and very low latency. But in order to actually gain access to the resources, a few things needs to be done. We need to add an additional IP, which Amazon provides for a loopback. So basically, just to explain why this has to be done is, by default, if you go to tunnels page, and this is why I have brought up other tunnels, you can see actually that we have a bunch of tunnels, and the loopback IP used is 10.100 something range. So AWS does not use that range. So Frankfurt uses 10.100.14, while the AWS has their own fixed range, and they've documented this. So we require a small change on our end to add a secondary IP. Whoops, sorry, I used the wrong. I used the notes instead of this. Sorry. So basically, we need to add the secondary IP, which is the in order to be able to reach the next hop, and the secondary IP is actually this inside. So this IP, and to do that, we need to go to Frankfurt. So right now, just to demonstrate what I'm talking about, if we try to ping the gateway, probably will not be able to ping it unless something changed. So no, it's not being able to ping it, the next hop. So we need to add assign the new IP, and to the tunnel loopback interface. So we need to do ifconfig, and the tunnel loopback interface is this one, it's VPP2. So to do that, and if we do IP adder show, you can see that right now it has 10.100.0.14. So what we're going to do is IP address add, then we open the document. We use the inside IP and make sure to use the cider as well. Customer gateway, add dev device VPP2. Just to double check that I didn't. So 206, yes, that's correct. And now, just to make sure I'm looking at the right time. Yeah. Okay, good. We're good. And now if I do the same command IP adder show, we can see that there are two IPs. There's a loopback that we have, because we have also fixed loopback addresses, and Amazon has fixed loopback addresses. So in order for this to work, we need to have two IPs, but the VPP2 interface has to have, a tunnel loopback interface needs to have two IPs. This is something that also we're working on, and we'll make this a lot easier in future. So now, if we open this document again, and if we try to ping the next hop, always when using the command line, use a fixed number of pings, otherwise it will just continue ping it in the background, and you're not going to get anything from it. So now we are pinging the gateway, and now we are able to reach the remote resources, and this is basically how it looks. This now means that this tunnel is connected and established, and there is no further communication. All clients from LAN side should be able to now access the resources on Amazon. So let's just go and create a secondary peer. which, as I said previously, Amazon offers actually in the document, you can see there are instructions for 2 peers, for two IPsec connections. So they offer this for redundancy, which is great. So flexiWAN can also use this for pet selection, for example, the video that we had the lesson that we did last week. You can then do load balancing or failover, or even just use quality-based routing and route everything important across to Amazon and so on. So again, to repeat, we do this, and we change the ID type to IP address. Local ID is automatic, and let's just scroll down to the second one. So we're basically adding a completely new peer in the terms of configuration, and here the tunnel interfaces is outside IP address for virtual private gateway. It's this one, and for peer monitoring, we're using the next hop. That should be it. Now we've created the AWS path label, so I'll also assign it here, and I'll do this. And now that we have a path label assigned, I go to actions, and we also configured the peer, secondary peer. We're just going to create another peer connection. We're going to select AWS2 to match it. And here are the tunnels. In a few moments, it should be able to connect to the peer. And let's go back to network. So right now AWS2 is still not connected, but hopefully it will, assuming that I entered actually everything correctly. Let's make a quick check of everything. So the virtual private gateway outside 70, remote IP 70, next hop is okay. Bingo, and it's connected. So now when you go here to traffic, sorry, I clicked a little bit too fast. So if we do this, now see that actually we have 2 tunnels from Frankfurt to AWS. And we have to repeat the same process if we want to. The second tunnel is now 16 loopback using. Again, it cannot communicate to Amazon's loopback until we add a secondary IP to it. So to do that, we're going to do IP address show. And we see that indeed this is VPP3. So I will be using now the virtual private gateway IP, which is this one, and the command will be IP address add VP3. So just to double check, we're adding the secondary tunnel. Yes. So secondary tunnel, internal virtual private gateway. So I almost made a mistake. It's not. It's this one. It's a customer gateway. So yeah. See, this is why we have to check things. So now VPP3 send command. Show. We'll see that VPP3 has 2 IPs, and moment of truth, if we can ping the secondary next hop. Hopefully I didn't get confused, but yeah, that's it. Now we have created and established the both tunnels, and the data is now, if we do filter by peer, any basically, it's just yeah, let's filter contains. You can see that we have 2 peers, and yeah, that's it in the terms of AWS. For the AWS, this is how you do it. So we just to recap, because we showed how to configure on both flexiWAN side and also on AWS side parameters to have two tunnels connected. And from here, we can then, because we use path labels, you can then use path selection to route all or specific tunnel traffic through AWS, added security to reach resources, even company resources, and so on. So yeah, that's it in regards to AWS. Since we have a little more time, I wanted to show you a little bit about the secondary peer that we have, which is the third-party device. So in this case, we're using an open source firewall called pfSense. Also, OpenSense will work, and we have configured it to connect to the Madrid. So in this case, I can actually showcase here. I'm not going to go through the configuration, but I'm going to at least show you the parameters. Is how to get the tunnel working. So let's just device contains Madrid. So here, by the way, I'm sorry if you hear some background noise. Neighbors are renovating. So basically here we have a third-party router, which in our case is pfSense. And if we go here, I'm going to increase it to fonts. So here we have a device which are already connected IPsec. So I'm just going to go through the settings and draw all the parameters that I did in order to establish tunnels from flexiWAN to pfSense. And to do that, you have to go to IPsec, the Services IPsec tab. And here you can see we've added two phases. Things to pay attention is you have to add, you have to choose IPv2. You have to make sure that your interface, with WAN facing interface, is selected, that the remote gateway is, which is the flexiWAN WAN IP, and the authentication methods are my IP address, peer address is the identifier, and pre-shared key, which you shared and define actually here either on PFs. Just make sure that you use the same pre-shared key. Basically, that's the point. And from there, make sure just to use these encryption algorithms settings. All the pfSense uses 128 bits by default, switches to 256. Everything else can be kept as default. And then when you do that, add phase 2. So here comes the a little bit tricky part. We suggest that you use routed VTI in order to have pfSense give you IPsec as an interface, as an actual interface, then which you can add it, and then you can add static routes and route specific traffic through it. And to do that, you will need to first select routed VTI, and when you do that, the network section will show up. Here, under that, you have to define two loopback, basically two IPsec point-to-point interface tunnel networks. It's completely pfSense side. It's not really used anywhere other than pfSense. So just define random non-used network range. In our case, it's just 410 and 411. Also, from here, just pay attention to use under phase 2 proposals, use ESP, AES 256. By default, it's 128 on pfSense, so just switch it to 256. Keep everything else as default. Then when we go here to IP status IPsec, you can actually see that we have already connected and to the Madrid device, and we have everything connected. However, there is no communication. So from both pfSense side, again, pfSense is not an SD-WAN solution, and it's a traditional networking approach. So it's not SD-WAN. So manual work needs to be done in order to actually have all the bits working and all the data, all the networking flowing. To do that, we have created IPsec, and we have confirmed that we have connected, but we still need to go under interfaces, and because we use the VTI, we have to add IPsec VTI as an actual interface, which I already did here. Just enable it, don't configure anything else, because already it has an IP 410. And from there, now that this has been added, now navigate to system routing. And from here, you will see that we have a gateway now. And now that we have the gateway, now we can also route traffic across it. And in order to be able to reach flexiWAN, you need to add 2 static routes to use that are using this gateway as default. And one is used 110.100.0.0/24 to route it across the VTI gateway, which is the loopback range of our flexiWAN internal tunnel loopback. And the secondary is the LAN network of the Madrid, which is 192.168.77. And now we can also reach the LAN side. Once you add that, don't forget to add a firewall rule, which is, I just allowed everything basically on IPsec tab. And from there, you can, you should be able to reach. So let's, both sides should be able to talk to each other. So let's actually try the LAN network here. Let me, oops, something is frozen a little bit, but doesn't matter. So basically, I lost control. So basically, the LAN network is 192.168.23.3. So let's try to ping this IP if I manage to select it. So from Madrid, we want to be able to ping the LAN side of PXS, and indeed we can. And the reason why it does that is because we've added these routes, these static routes. However, what's also needed is to add the same static route to of the LAN side to use the gateway on the tunnel gateway, which is in our case in Madrid is 10.100.0.10. So, and now if I go back here, this is added, and now the both ends can work fine. So yeah, as we're approaching to the end, oops, sorry, just checking if there are any questions. No, there are no. If there are no questions, I'll give you a few moments basically to ask. But that's about it. Basically, to recap, today we covered how to deploy flexiWAN peering with AWS. We showed you actually that, and then we also covered how to briefly connect to third-party routers such as pfSense, OpenSense, but we also tested it with Meraki, Cisco, various Cisco devices, Checkpoint, and so on. So yeah, that's about it for today. Thank you for visiting. Thank you for watching, and we will be uploading this video shortly, and talk to you soon for yet another webinar lesson. Thank you.